I'm Dylan.
Hey, Tristan.
And we are going to be making cookies, but with chemistry. Not that there is any difference. Now, the first thing we need is aprons.
Thanks. Here are our ingredients.
First, we have baking soda. Then, we have salt. Then, we have some vanilla extract. It smells so good. Nope, I spilled it. Then, we got the butter. And then we have all of our sugar. We got our corn syrup, our brown sugar, and our white sugar. And then we got our milk, our chocolate chips, our flour, and then a large egg.
Stop. That's not even large to start with. That's like a quail egg.
It's a large quail egg, though.
Give it here. This
One large egg.
large chicken egg. So let's get started.
How do we start?
Well, first you're gonna hand me the ingredients, and I'll do the mixing.
Okay, here's the baking soda. Salt.
Sure.
Okay.
We're just gonna, anything that's not wet, just give it to me. So like, give me the.
How about this vanilla extract?
Put that here before you make any mistakes, sir.
Oh.
Just give me the flour.
And the chocolate chips.
No, that's at the end.
Oh. How about this? Powder.
It's flour. This, we're just gonna put it in here as we speak, cause the sugar.
Did I just put the rest in this bowl?
So what's going on here is a physical change because, yeah, this technically could be reversed, but very concentrating work, and yeah, I don't have the brain for that. And what would be going on here, sir?
So, what I guess is happening is when you mix the liquid with the dry, then the baking soda
Which is over there.
kicks in and starts releasing carbon and dioxide gases, which puffs up the cookies in the oven. And it's irreversible in a chemical change because you can't change it.
Oh, look, the lights change.
Look, this butter's really cold. I gotta warm this up.
Okay, so what he's about to do is use heat transfer through radiation to sort of melt the butter a little bit. Just don't drop it, please. Radiation. Butter and the sugar. And I'll put one large chicken egg in there. So now that everything is mixed up,
It looks like a homogeneous mixture.
okay, so he's gonna take it and pour it in here. He's gonna take his bowl, pour it in here, make sure all of it is in there. Yes, I'll use that. Yeah, that would be really helpful, my friend. Thank you so much. Yeah, thank you.
You're welcome.
And this is where the chemical reaction should be happening. Yay. I'm watching you, just so you know. They say cooking is messy. I'm about to prove it.
Shouldn't we be using spoons for this?
They say cooking is messy. I'm proving it right now. Now just start while I wash my hands. What the? Now that that hectic moment was over with, we're gonna start making the actual cookie.
Right now, these chocolate chips are solid, but once we put them in the oven, then they will become melted and become a liquid. However, if we put them in water and make it really, really hot, the chocolate will then become a gas and just fill up the entire room.
We
with
open up
chocolate.
the oven and we'll inhale the sweet smell of the chocolate vapor.
Put these in the oven now.
So while he's doing that, aside from the idea of convection for inhaling chocolate vapor, there's also the idea of conduction because these it's a metal pan, so it will transfer heat to the cookies, and there's also obviously radiation in there. So yeah, same thing as the microwave. It'll help them do what they need to do. be science if we didn't change anything.
But the only difference between science and messing around is writing it down.
So what are our ingredients now, Dylan?
Well, we still have the salt and the vanilla. However, if we replace baking soda with baking powder, we got the butter, we got the sugars, we got the flour, we got the large egg.
That's not a large chicken. That's a duck egg.
But it's a large one.
One large chicken egg.
A large egg, and some more chocolate chips.
Chicken egg.
Yeah. The baking soda ones are rather thin.
And the baking powder ones are quite thick.
Now we're going to taste both of them.
This is really good. It's like really, it's sort of crunchy, but at the same time, like it just melts in your mouth because of something.
This one is rather crunchy and it kind of pops in your mouth. Just. And so now we are going to move on to the second trial with the milk. Right.
The milk.
Let's dip it.
Dip it.
It's been
Dip it.
dipped.
Way much better with this.
So, when I dipped it in the milk, it lost its poppiness as it was replaced by a cool, crunchy, chocolatey feeling.
Right. I had to say something about it when I dipped it, but it was just like less, like more, like it melts in your mouth still, but it was just pure heaven. Pure heaven. Just got up.
Alright.
Just got up. 3, 2, 1.
This one is a bit soft.
That's the word I was looking for.
Not that crunchy as this.
That's the word I was looking for.
It's squishy.
It's still pretty good when you dip it in the milk. So
What
this,
do you think of that?
yeah, it's pretty crunchy, but like when you get to the middle, it's pretty soft and it just makes it perfect.
Time for the second trial. Right.
Dip them.
3, 2, 1. The taste stayed pretty much the same. It just got a bit colder. It's like a refrigerated gummy bear.
Yeah, that's another one I was looking for. Like it was still soft, but this one it was good. Like it was a little bit softer, but it kind of lost its a bit of its flavor until you get to the very end, and then swallow. Then it's good.
Well,
Just 'cause-
now,
just 'cause.
which one do you think you'll like the best?
You don't mind if I ate all of them and find out?
All right.
They're really good, but I think that these ones are pretty good.
Yeah, I would agree with you there because these ones taste like a bit more sweet, and I like the poppy sense in your mouth. It's like this.
So for the second part of our experiment,
This time, instead of replacing the leaven each time, this time we are going to be replacing the fat, and instead of butter, we're going to be using coconut oil.
so we decided that the baking soda recipe was much better than baking powder, so the recipe is the same.
So we got the baking soda, we got the salt, we got the vanilla extract, we got the milk, we got the coconut oil, we got the sugars, we got the flours, and then we have the large egg.
Yeah, this time it's a large chicken.
It's
Bro?
a large egg,
Bro, that's a goose egg. That's a goose egg. That's a goose egg, my friend.
but it's a large egg.
It's a large goose egg. We're supposed to have a large chicken egg. Chicken egg, for Pete's sake, chicken egg. Now one thing, that's a good thing I did. Until now. No. This is why I brought him late.
Now you're gonna put them in.
Exactly. So this is our grand finale.
Now this time for the fat, we are using Crisco vegetable shortening.
And of
And-
course, the recipe is the same aside
So-
from Crisco.
We still have the baking soda, salt, vanilla extract, the milk, the Crisco, the sugars, the flour, and the large egg.
The large egg, yes, this time it's a chicken egg. And
Wait.
where's my... Dude, my friend, this is an emu egg, not a chicken egg. This is like not even the size of a large chicken egg. Give me this. So on. This is a chicken egg. This is not a chicken egg. This is... chicken egg. Final ingredients.
Get all of them.
Yeah, that's all of them.
Convection.
Looks like this guy got a burn.
hand.
Here, Insta Ice Pack. Take this burn here. And up. Crap, my hands are actually really cold.
Here.
Endothermic reaction.
Here, have this hottie.
Thanks.
All right. Exothermic reaction for you.
Yeah, thank you very much, my friend.
You're welcome, my friend.
There's one more thing that we needed to talk about. Take it away, Dylan.
Right, so, it's the reason why the cookies poof up. And it's carbon dioxide. Because in carbon dioxide, carbon and oxygen are bonded to each other by means of covalent bonds. That's why this compound is covalent. Keep in mind that covalent bond is a type of bond that is formed between two atoms by sharing electrons between them. So carbon dioxide is a covalent compound, not ionic. And the trapped carbon dioxide causes the cookie to poof up, making the cookie even better. Information for the carbon dioxide and covalent bonds is thanks to
Quora.com. Back to taste testing with our second experiment.
Right, so this one is coconut oil, and this one is Crisco. So, 3, 2, 1. Really, still crunchy. That's a fact.
Same thing.
But it's in my opinion, a bit more oily, kind of, and doesn't really have a popping sensation in your mouth anymore.
This one is sort of poppy, but the Crisco gives it a very interesting taste, like a good, interesting taste.
Does it taste like vegetables?
Sort of. Let's
Three,
just
two,
dip
one, go.
it. Let's forget about it and dip it.
Literally the exact same thing, just cold.
It's sort of the same thing, but it improved the taste a lot more.
Alright,
Let me just kill it real quick.
right. Last one. I think it tastes kind of a bit more oily, and still has the poppy sensation. It kind of has the aftertaste of vegetables.
I know, that's the good part.
Yeah.
This, yeah, it tastes a bit oily, but like, it's like oily but weird, but it's still okay.
Still crunchy.
Big dip.
That kind of added on to the smoothness of it in your mouth. Because of the oil and the milk combined. Still has the aftertaste of vegetables. Everything was the same, except it's a bit more smoother in your mouth.
Same thing about this one, and then the milk. That certain taste. I cannot find a good word about a word for it, but the milk made that taste a lot better. Just stick the whole thing in there.
I kind of like the Crisco because it's a bit smoother going down, and it goes down nice and smooth, and it has a nice aftertaste aroma in your mouth. Yeah. And what was yours?
Same here with this Crisco. It's like really good, and then the aftertaste of the veggies. I just want to have salad now.
Thank you for tuning in.
Thank you for tuning in. We'll see you next time.